Good morning. Nathalie Leblanc, c'est Mustafa Mourchid. I hope you're doing well. And Ramadan Kareem. صحة وسلامة إن شاء الله والأجر. Thank you very much. Thank you. So let's wait for the other. Hello, Mr. Buknifi. You are the third to say hello. I'm sorry. Mourchid and Natalie are still the highest. Never mind. Okay, thank you very much. We have. Okay, Ustad Atimat, thank you. Si Meju Hassan, thank you very much. Thank you, everyone. I'll take some time to share this, and I request that you do the same. Please share the link to this live in your groups and on the platforms that you are using so that we can have enough people with us. Okay, so this will make me absent for 3 to 5 minutes, perhaps not 5 minutes anyway, but just the moment, the time I share this on the platforms. Okay, this one. The groups. I don't have groups. I don't have many groups there, but linguistic studies. I think in linguistic studies, Si Mustafa Morshid is always the one to take this generous initiative of sharing this on sharing the links to the live sessions on this platform. So let me switch to your academic companion here. Hoping to have more people with us, or not hoping, but waiting anyway. Hoping, we're not hoping, people who are interested will join. Okay. Okay, I think I have done what is necessary to share the link to the different platforms. Perhaps we are expecting more people to show up before we start. So let's just spend a few minutes, let me spend a few minutes responding to your greetings. I think I read until Si Hassan Majou, Atimet, I think I greeted you back. Thank you very much, Si Hassan, Atimet, Si Hassan, Si Mustafa, Ramadan Mubarak, Saeed, Ramadan Kareem, everyone. Ramadan Kareem, Si Mohamed Bouknifi, Si Youssef. Hello, Si Yusuf Obadi. Ramadan Kareem to you as well. Gulmi Matichin. Hello, and Ramadan Kareem, Si Mohamed. Lazraq, hello. Ramadan Kareem to you too. Thank you very much. Anas Shakib, good afternoon. Thank you very much. Sisqati, welcome. Thank you very much. Ustada Hind, hello. Ramadan Kareem to you as well. Ustada Hind. Fidwa Iraq Raqi, Ramadan Kareem to you as well. to you too, Fedwa and Faiza. Hello, Faiza. Ramadan Kareem. Thank you very much. She is greeting the professor as well as the people, watching us here. Thank you very much, Faiza. Okay, Ramadan Karim, ZLM. Thank you so much. Yusra Al-Hamid, I think we have some new names here, which is nice. You are welcome. This is an opportunity to hail them all and to welcome them. So Yusra says, Ramadan Mubarak. She says, good morning. Thank you very much. Salahuddin Salmi. Hello, Si Salahuddin. Thank you very much for the encouraging word. Ramadan Karim to you. Ramadan Karim, Sisqati and Maryam Abu Abdel Majid. Ramadan Mubarak, dear Professor. Ramadan Karim to you as well. Si Ammar, Ramadan Karim, thank you. Imad Al-Firawi, Ramadan Karim, thank you very much. Sada Samia, hello. Wishing you and everyone blessed and peaceful Ramadan. Thank you very much, Sada Samia. I wish you a happy Ramadan as well. Thank you very much. Alors, do you suggest that we go directly into the points that we are going to discuss today, or do you think that we should wait until probably more people join us? In the meantime, I request that you hit the like button, and those of you who can share, those of you who can share the link to the different platforms and to the different groups, please do so. Okay, I have an explanation to the reason why 27 people are watching me and with 7 likes only. It's because it takes a lot of energy to press the button, because it's Ramadan, because the people have not had the breakfast. So it's normal for people not to be able to press the button. I'm just joking, okay? So let's just welcome our dear colleague, our professor, Ustada Khadija Anas Muhtarama. She is the one behind this initiative, honestly, and we agreed to to reserve this session from my YouTube channel, so that most people, many people, or enough people at least, will join and will benefit. This only translates how generous she is with her students. Thank you, Lila Khadija, and welcome in this live session. Again, I'd like to make this final request that you share this so that we can have maybe around 40, so that we can start our discussion, probably not in as energetic a manner as is the case when we do it at night, but in the evening. But anyway, I'll try. I'll do my best. All that you need to do is follow. I prefer that we reserve the first half, or the main part. We will talking about the main theme, which is correlation. Yeah, and then if there are individual questions relating to individual people having problems with the thesis, or questions for discussion, we can leave them until the end. Okay, so well, I think we need to go straight to the point, because now it's 10 minutes past, so it's a good idea to start our lecture on the notion of correlation and its relevance to scientific research in the field of social sciences, of course. The points that I will be discussing are points that assume no a priori knowledge on the part of the viewer. That is to say, you will be able to follow our session here on correlation today without necessarily any working knowledge in the field of statistics. Anyway, we will not touch on the aspects that are very technical in this session. Initially, the idea was to lecture on correlation and regression, but because there will be people with us here who have not been introduced to statistics, because there will be people here who may not be able to follow for probably a long time, maybe 3-4 hours, because talking about correlation and regression with examples and with by showing how to go about, for example, doing the statistical analysis on SPSS, requires a lot of time, requires a lot of energy, and more specifically, it requires enough, prerequisite knowledge. So I chose to do away with anything that requires a priori knowledge in the field of statistics. So let's start from scratch. Of course, there will be issues I will be touching on that are unlikely to have been covered by some of the students, but I will just point to them, maybe put them between brackets, and we will return later on. We'll come back later on to the the explanation of those concepts. For example, the measurement scales. That's one thing, and differences among variables, descriptive statistics. All these will not be the object of discussion today. I may point out to some of them, but it does not follow that they are part and parcel of the main contents of the session. All right? Yes. Okay. So the points that we are going to cover, we have 4 points to cover today. 4 points. If we manage to understand them with relevant examples, then we can assume that we have succeeded in explaining the concept. The first point is understanding the concept of correlation and its role in social sciences. So that's more of an introduction to the this live lesson, let's say. The second point is to differentiate between different types of correlation. Of course, we cannot talk about the different types of correlation if we don't spend enough time explaining what correlation is. So this is what we are going to do in point 2, basically. And then we will move to the discussion of the difference between the parametric type of correlation and the non-parametric part, and when to go parametric, when to go non-parametric, and we will explain what parametric is in the first place. Of course, we will not delve into the details because these things need an independent session. But I guarantee that the way I will talk about it probably will, be will be understood clearly, hopefully, by our friends here. And then, of course, the last point that we are going to address relates to the assumptions of the correlation analysis as well as its limitations. All right. So let's start with the first point. What is correlation? In order to talk about what correlation is, we need to point out that, because especially that we have people here who are real beginners in, true, absolute beginners in academic research. So when you conduct research, you can go 2 ways. You can choose to go either left or right. By left or right, I mean there are 2, approaches, 2 ways you can conduct your research. Either conduct your research by analyzing data in the form of numbers, or by analyzing data in the form of language. For example, if you analyze the pronunciation of students, for example, while you observe them, for example, you can take notes, for example, of the types of mistakes in pronunciation. So what you are analyzing here is the language. That's one way of doing it. Just analyze, point to the mistake and say, for example, whether it relates to the pronunciation of vowels, to the pronunciation of consonants, to the pronunciation, or to the mistake in a phonological process or in stress. That's it. You don't give any numbers. You can do the same if you choose, not if you choose, but this depends on the way you formulate your objective, your hypothesis. I always say this. You can analyze the same issue quantitatively. That is, quantitatively comes from quantity, from numbers. Of course, there are numbers, things that exist in the form of numbers. For example, someone who analyzes the pronunciation of students can convert the number of, instead of just talking about the types of mistakes and analyzing the types of mistakes, they can calculate the frequency. For example, 60% of the mistakes relate to vowels, while 40%, relate to consonants. So this is a very simple and direct and straightforward example of the two major approaches in research. The first approach, which works just with words, with language, with analyzing language, is called qualitative data analysis, or the qualitative approach. The approach that uses numbers to come up with, for example, a result like 60% of this, phenomenon, or and about the phenomenon, 60% of the students, for example, produce this, pronunciation, while another percentage produces the other. Here what we call is what we refer to. So here we are talking about quantitative data analysis. See, Mamoni, my friends, I will come back to your comments probably after I am done with these things, unless there is a question, like the question by Simamuni Mohsin. He is talking to us about qualitative. Later on, Simamuni, because I know that you are an S4 student, that you want to know, because probably next semester or next year, you will have, to work on a project, on a research project. Qualitative in research, this is in research, qualitative means that you analyze, that your analysis is the analysis of language, the analysis of words. For example, I can speak for 10 minutes and you can come and analyze what I have said. I said this here, which can mean, blah, blah, blah. The professor means this and this. This is qualitative. Now, quantitative is something different. Quantitative is when you don't analyze the language, but you calculate, and there are some operations in statistics that we will see, and then your results are based on numbers like percentages. Now, let me close this. Okay, good. So qualitative data analysis, quantitative, this now, okay? Now, what can we do in qualitative data analysis, especially using the branch of statistics known as inferential statistics? I guess you know what inferential statistics is. Okay, so in statistical analysis in general can do one of the three things here. Okay, let's say one of the four, because it can be used to explore data, just explore, like knowing, for example, how many males and how many females, produce a given sound. Always sticking to this pronunciation. Okay. Mamoni, no, not research, that's search. Not research over Google, but that's maybe for your research في البحث اللي غادي تدير ان شاء الله في السنوات المقبله. Okay, so I'll close this. So with statistics, what can we do? Statistics, we can explore a given phenomenon, a given issue. That's number one. With statistics, we can compare X, Y, or X, Y, Z, etc. Okay. So, for example, when you compare academic level, when you compare students, different academic levels on the quality of their writing, or on achievement, or on their motivation, here what you are doing is comparing, because the variable of academic level is one that leads to a comparative measure. Excuse me, my friends, I need your feedback about the noise that can be heard outside. The kids are playing there. I know this is a place where kids gather to play, and when they play, they make a lot of noise. So I just wonder whether you can hear me without problems. I need your feedback on this. Okay, so let's just proceed. So with statistics, we can explore. Thank you, Gulmima. Thank you, Gulmima teaching. Thank you so much. Okay. So I said with a statistical analysis, we can explore. We can use it just to explore, to know percentage of something, for example, or to look for a number that represents, I don't know, a given population. But we can make it to, there are what we call measures of associations. And this is, by the way, this is what correlation analysis represents its measures of associations. That is to say, with statistics, we can observe whether, we can detect whether variable X is related to variable Y in some way. Okay, variable Y in some way. Oh, Y, I'm sorry. So let me say it again. Through these measures of association, we can achieve the following: check and discover whether there is a relationship between this variable and that variable, and by definition, other variables, of course, because we can check the relation of a number of variables. If a number of variables are related to each other. Okay, so this is this. So we have measures of exploratory data analysis. We can have measures of comparison, like comparing male and female, city 1 versus city 2, country 1 versus country 2. And then we have measures of association. Association means that we have variables and we want to see whether they are related or not. And there is another category of what we call the uses, another use that can be made of another purpose that statistics can serve. It's the measures of prediction. Okay, measures can predict. They can predict, for example, in marketing, there are certain measures, statistical models, of course, that can be applied and that can predict, for example, prices, that can predict the future state of the market, etc. Okay, so these are the ones. Now, we are not going to talk about the first exploratory measure, the first exploratory use of statistics. We are not going to talk about comparisons. Probably that's going to come in a series of other videos. Now, today we are going to specifically talk about this measure known as correlation. Correlation simply is a statistical measure. Okay, of course there are types, but as a family, it's a statistical measure that that tries to establish or to detect relations between variable X and variable Y, and for that matter, variable X, variable Y, variable Z. There is a way we can do that. See, and in social sciences, working by means of using the statistical measure of correlation is, this is a practice that is so widespread in social sciences. Let me just give you examples of research questions that can, lead to, a correlation analysis. For example, in the field of education, we have maybe, this research question as to whether, because some students believe for one reason or another that they did not do any work during the semester and yet they got a high grade. To what extent is this credible? Okay, so just in case you make a gesture like this and you want to explore this, for example, one thing you can do is to ask the research question as to whether study time, the amount of time spent on studying during the semester, correlates or has a relation, or there is a relation between the amount of time spent on work during the semester and the exam score that is obtained, that is achieved at the end of the semester. So this is a good example that can lead the researcher to adopt a correlation analysis as a statistical measure to answer this research question, to support the Inchi-Win hypothesis and reject the Inchi-Win, null hypothesis. In sociology, we can probably have this question about the elderly, old people, for example. By the way, we need to define what old people are, the term old people. And the elderly, probably many of them are retired, many of them are not involved in activities, and therefore they spend, probably, we don't know, but they spend more time watching TV than the young generation. You see? So here, this probably, if this is subject to an academic investigation, we can say that watching TV is a variable, And age is another variable. Is it the case, for example, the older people, the older people are, the more time they spend on TV? Of course, this will depend on different places, on different countries, on different cultures, and so on and so forth. There are other variables that can intervene, but this is just an example to show that there are, there are examples from all the social sciences. So I have brought up this example from a possible research paper in sociology, research question, sorry, in sociology. For example, in psychology, you can, psychology, psycholinguistics, you can, for example, uh, uh, observe that, for example, some children start stuttering. Okay, you know what stuttering is? Stuttering means they repeat the first parts of a word, probably first syllables, and then before they say a word. Is this due to anxiety or is it due to other factors? This is probably worth investigating. And okay, so one can ask this legitimate question as to whether stuttering is related to anxiety or to stress or to any other factor. This is just an example. Okay, so here again, this is a good example that can be conducive to a correlational analysis. Now, just to wrap up, 2 points have been made so far. Point one, for the beginners, there are two approaches, the qualitative, the quantitative. We will not dwell on this, and we have not dwelt on this. Okay, now, the second point that has been made is that correlation analysis is one of the three or four, okay, functions of a statistical analysis, of using statistics, you know, for data analysis. We talked about comparison, we talked about association, we talked about predictability or prediction. So here we are talking about correlation as a measure of association. Now, let me just talk about, use the board. Okay, I can use the board to talk about or to use, okay, to sketch different scenarios when we conduct a correlation analysis. Usually it's represented in a graph like this one here. Okay, so we have, for example, I don't know, I have another color here. I hope it's not a permanent color. Watching TV. So the age, for example, you start with 10 years old and until 70, for example, and the hours of watching TV, you start from 15 minutes, maybe to 400 or 500 minutes. Okay, so you can have this. Okay, this means that the two variables go together. Okay, this is one scenario. I am saying this because we will come to the numerical interpretation of these and the numerical translation of these in a moment. Okay, so this is scenario one. This is a possible scenario. Are they related? Yes, they are related. Why? Because they go together. When one of them goes up, the other also goes up. Now, of course, here we are talking about variables. Each line corresponds to a variable. What is scenario number two? Scenario number two is that, okay, when the age, okay, the lower the age, the lower people who watch TV. As you can see here, do they go together here? Yes, they do. Okay? Yes, they do. Are they related? Yes, they are, because wherever this one goes, the other one goes. If this goes up, this goes up. If this goes up, down, this goes down. Okay? So let's just have the other way. Now, what happens when we have a scenario like this one? Just imagine we have something like this. This goes up, and the other one, okay, goes down. This goes up, and this goes down. Okay? Is there a relation between the two? Yes, there is, but it's a relation of the opposite. Wherever this goes up, the other goes down. We will talk about this in a moment. Just understand the scenarios first, my friends. Okay? Now, let's look at the other scenario here, which is when you have, for example, something, a variable going up. Let's just try to think of age and the amount of time spent on watching TV. Okay? Imagine we have this. So this can go up, and this goes, not down, but on a straight line, for example. What does it mean? It means that these are not related. You see, where one goes up, the other is neutral. We don't know. So, or we can have something that is fluctuating or whatever. You see, so this is the idea here of the different scenarios that you can have, but we can also have, for example, imagine we have this scenario again. When something goes up, the other thing goes up in exactly the same way. Sorry. I use the black. The other one goes up in exactly the same way. So here, this is exact, the distance you have here is constant. It's the same, all right? Or maybe for further clarification of the thing. So let's say that when you have something going up, you have another variable that fits the same lines here. So you have two here, the black and the blue. Here they are. We say that the relation here is perfect. Perfect in the sense that they occupy exactly the same points. So these are somehow the different scenarios that we can notice in a correlation analysis. So a student, a researcher conducting a correlational analysis, will fall on one of these scenarios. Mostly it's one of these scenarios, all right? Fine. So let's introduce some terms here, okay? Let's introduce some terms here. When we have a situation in which, there is agreement, on the two variables, or with the two, between the two variables, there is agreement to go upwards together or downwards together. You understand? So we have variable 1, variable 2. When this goes up, that's agreement. Fine? When this goes up, this goes down, that's disagreement. When one goes down and this goes down, that's agreement. So we have agreement like this, up, that's agreement, down, that's agreement, up, down, that's disagreement. All right. So let's just expound these things, okay, by using some language and by introducing some of the relevant terms, or the terms that are relevant to a correlation analysis. Okay. So when you have a situation like this, when the two go upwards, so they go upwards, we are talking about positive correlation. What is positive correlation? It's when the two variables go in the same direction. I repeat, when they go in the same direction, we talk about positive correlation. How many instances of positive correlation do we have here? Sorry. How many instances of positive correlation do we have here? The answer is, it depends on whether we have the two variables going in the same direction. So, is this positive correlation? The answer is yes, it is, because the two go in the same direction. It's agreement. Is this positive correlation? Answer, yes, it is. Why? Because they go, you see, in the same direction. Okay, the other is, yeah, see. So, but this one here, this is negative correlation, means when one goes up, the other goes down. Yes. So Natalie is writing it here, right? So here, this is a good example of what? Of negative correlation, because one of them goes up, the other goes down. Okay. So when there is no agreement between, you see, the variables, it seems that there is no agreement here. One goes this way and the other goes this way here. It means that okay, here we have an absence of correlation. This is just a visualization of the thing. And here, of course, actually you see one, but there are two. They are exactly, okay, exactly, you see, on the same, line. So here we are talking about perfect correlation. Okay, nice. So let's just move on to the discussion of how can we tell, can we talk about positive or negative correlation statistically? It means how can we see a number and discover that, for example, there is positive or there is negative correlation. Okay, so let's move on, please. Okay, or just let's keep them. Okay, the answer that when you want to check the results, just imagine, because we will later on, probably next week, if possible, we will hold a live session and see if we can. By the way, I'll have to solve the problem of screen sharing before. Then anyway, we will see the details later. But look, in a statistical model that uses correlation, if you want to see mathematically, I mean, in terms of numbers, the relation between two variables in the form of a number, then there is one index that is called the R coefficient, le coefficient du R, the R. Okay, it's R here, equals, and then you have a number there. Now, if you want to interpret the this correctly, you should know about the standard. I mean, the values and their interpretation, that this is known worldwide. Okay. Now, if the R value, by the way, the correlation, the correlation coefficient, this R value ranges between -1 and +1. So it's between -1 and +1. In between, of course, there is this 0 point. And the values that are between 0 and -1 are negative values. For example, -0.1, -0.2, etc. Here they are positive. For example, 0.1, 0.2, etc., 0.9, and then 1. Okay, so this is what we refer to as the correlation coefficient. The coefficient. The correlation coefficient. So your interpretation in regard to the correlation coefficient should be based on this. Okay, so let's have a reading to this in order to know about the possible scenarios, or to translate these positive scenarios in our interpretation of numbers. Okay, so here, this is the R coefficient. R equals a value that comes between -1 +1. All right, good. So let's first talk about the if R gives us 1. 1 is one way of saying +1. with 5, it's plus 5. Okay? Minus 5 is minus 5. Minus 5 is well known. But either you put a plus or you don't put anything, it's the same. So just imagine the R value that is generated equals 1. Here, we say that the correlation is perfect. Okay? We talk about a perfect correlation. You see? That's the thing. Now, when it gives you a value of minus 1, it means that this relation between two variables, this correlation, is perfect, but in the negative sense. You see, you say a perfect negative correlation, a perfect positive correlation. So what is the tip here? It's whenever you see a minus generated for the R value, minus means negative. Call it negative. Okay? No minus with the number, call it positive. For example, if I have 0.3 or 31, let's say. Okay, is this positive or negative? Because I don't have minus here, I call it positive. If I have, so this is positive. This is positive. This is not positive. This is negative. Now, if you have minus 0.7, is it positive or negative? We need to use the word negative because there is a minus here. You see? So I hope we are clear on this. One dimension that we can use to characterize a correlation is, whether it's positive or negative, is positivity or negativity. Okay? Positive correlation, negative correlation. Good. Positive means going in the same direction. Negative going in different directions. That's the negative correlation. All right? Good. Now, let me clear this out. Excuse me. So if you have questions, my friends, please leave them until we will reserve a session. Not a session, but part of this session. If there are, probably things that you wonder about, or just an exchange with me on something, then we can do that. Yeah. So that we will not lose track of these things. Okay. Very good. Excuse the noise that this generates. Never mind. So let's. If it's 1, by the way, so we can talk about positive, negative. You agree with that? You agree with positive and negative? What is it that shows whether it's positive or negative? Answer: what shows that it's positive or negative is what? Is the minus or the plus? It depends on what you have there. If you have a minus, it's negative. Plus is. So let's move on. So this is one dimension. The other dimension, in the correlation, we have to use two adjectives, like strong positive or weak positive, or strong negative or weak negative. So you have to have this trade-off between, strength and directionality. Directionality is, okay, in terms of the positive, negative, and strength is, known as strong. But how do we know that it's strong? We can tell if it's negative, but how can we tell if it's strong? Let me show you. Now, if it is, generally, statisticians say if it's between, 0.1 and by the way, we forgot. Let me revisit this. 1 means perfect. 0, if R equals 1, it means it's perfect. If R equals 0, it means no correlation. It means they are not related. You see? No correlation. For example, if watching TV and age turns a result, an R coefficient equal to 0, we have good reason to argue that that age has nothing to do with watching TV. And watching TV has nothing to do with age. You understand? Okay, so I just forgot this. Now let's move on to this. Okay, so between 0.01 and 0.03 or 0.3, شوف I can either write 0.1 or just 0.1. هل 0 point something هي point something. So if you write 0 here, it's fine. If you don't write it, it's fine. So let's just say between, okay, let me write 0 like this up. 0.1 and 0.3. Okay. Is it positive or negative? Is it positive or negative here? Between يعني عندي 0.01 or 0.02 or 0.03. Is it positive? Yes, it is. So this is a positive. Yeah. Okay. Is it strong or weak? Is it strong or weak? How do you know? How do we know if it's strong or weak? We know that it's strong or weak depending on whether it's close to 0 or close to 1. نشرح لكم. If a value, so let me use the AR structure, the comparator. The closer a value is to 0, the weaker. The closer a value is to 1 or to -1, the stronger. Now we will judge. So 0.1 is up. Okay, 0.1, 0.2, 0.3, they are very close to 0. It's not like 0.7, 0.9. So this is positive, yes, but weak. So we can speak about weak positive relationship or weak positive correlation. You see? Okay. If it's between 0.3 to 0.5, here we have reached the middle point. Between 1 and 0, you have this 0.5, 0.4. Is it strong? Not really, because it's not 7 and 8. Is it weak? Not really, because it's not 0.1 or 0.2. We speak about here a moderate correlation. Is it positive? Yes, it is, because there is no minus. So we talk about here positive, moderate, or moderate positive correlation. Moderate positive. Okay. Generally, when it's between 0.05 and 1, it's closer to 1. 0.5, 0.6, 0.7, 0.8. Generally, we are talking about the opposite of weak, which is strong. Okay, so here we talk about a strong. Is it positive or negative? It is positive here. So these are the scenarios. Now, can we just change, imagine, because so what we have here is, okay, is between, I said that R, the result that you will get on SPSS, we will talk about the details later on, they range between -1 and 1. And here we have 0. These values start from here and in here. All of them are positive. لان هنايا كنديروا لي بلس ما حدين غادي لهاد الجهه كنديروا لي موان. علاش؟ لان تحت الصفر احنا جينا ل -1. Okay, so here this applies. So we have 0.1, 0.3, it's somewhere here. 0.3, 0.5 somewhere here, and this is here. So all of them are positive. And we started from the weak, it's here, moderate, and strong. Now the question is, just imagine we have minus values here. For example, instead of 0.1, we have minus 0.1 to minus 0.3. It's the same for weakness, but positive will become negative because of the minus there. And we will be talking here, the mirror image. Is that okay, my friends? I hope I have been able to probably talk about some of the, this is the core information that people need to know about correlation. It's how to interpret it and what use can be made of the data in the form of statistical, of numbers, of course. Okay, I just wonder whether I can take a few minutes here just to read these. It's probably a break that I'm taking. I don't know where I can start from. I hope I have not missed any of your comments. By the way, if you feel that you have inserted a comment to which I have not responded, it means I have not been able to read it. Paste it again. Thank you. سي عبد علي فقير, أهلا وسهلا. How are you? I hope you are doing well. And Ramadan Kareem. Okay, I'll skip Bugnifi, Natalie, height and weight, thank you. Okay, discourse answer, I don't know where you say that. Si Mustafa is talking to Muhsin, I guess. Ahmed say it's clear. Murshid, content analysis, guys. Okay. Strength, direction. Yeah, that's true. It's the strength and the direction, and this is exactly shown in the terms like positive, negative, and weak, moderate, strong. Okay. اوكي ماموني اسمح لي نجاوبك على هذه غابيدمون. سي ماموني محسن، الا بغيتي ولدي دير لابريفياسيون هي بحال داك الكتابه ديال البروفيسور، واش كنكتبوها بي ار ولا بروف. في اللغه الانجليزيه كنكتبوا بروف بي ار او اف ودير واحد النقيطه تما. بي ار بوين هذيك ديال الفرنسيه. دونك ندوزو. Okay, we have so there is this what's happening here? Oh, that's just a little thing. Okay, what's in is saying vertical. Nice. Aisha Mqrini, hello. Thank you so much. Thank you, Aisha. Thank you, Aisha. You are welcome. And Ramadan Kareem, Qamar Yusfi. Thank you so much, and Ramadan Kareem to you too. أهلا سي عزيز شبراوي, أهلا وسهلا. Ramadan Kareem, and thank you, سي عزيز, for joining us here. Thank you. This positive correlation when one variable increase the value. Yeah. I read this comment before. Natalie, okay. I'm just looking for whether there is something that I need to respond to. Mamouni Muhsin, for a number of years, Mr. Mamouni Muhsin. It's more than 16 years. I'm starting the 17th year so soon, 1 month or so. Natalie, Mamouni. Yeah, Si Mohammed Bouknifi, you are right. Natalie and Murshid, they are doctors before they are actual doctors, before they get the diplomas. Okay. Nice. Faiza, a perfect positive correlation. When one variable increases, the other increases at the same rate. That's true, Faiza, at the same rate. Because when they increase at the same rate, it means they are it's a variable correlating with itself. You see? Variable watching TV and watching TV. You see? They have exactly the same values. They have a correlation of 1. Definitely tableau when you get the results of of the statistics of correlation, when you have a variable in one cell meeting this itself, I mean the same variable, you have one there in the results. Okay, Sinuddin Baba he is here with us, but I think there are comments. Yeah, Mustafa. Okay. Maha أو أف والله. Okay, thank you, Maha, for joining us. I think this is the first time you join us here. Thank you so much. Okay, Nordin Baba, Ramadan Kareem to you and to your family. Weak, moderate, and strong positive, negative correlation. You summed it up all. Thank you. Correlation for prediction, correlating students' national English exam scores. Yes, yes, yes. But I'll talk about this issue of prediction in a moment. Mr. Lazraq, thank you for for pointing this out. But in any case, it was in my schedule for today. Good afternoon, Nawal. Thank you very much. And happy Ramadan. Nuni Nunus, yes, indeed. Yeah, I don't know. She was probably responding to a comment either by myself or by someone else. But thank you very much, Nuni Nunus, for joining us here. Everything is clear. Thank you, Professor, she says. Okay, now that we have talked about these things, by the way, this course will not be involving this session. I mean, it's just for these concepts. Okay, 1 hour has already elapsed, and we are still, probably we are still trying to cover in as clear a manner as we can afford the basics of correlation. I think we have reached a point where now we can talk about other things. Okay, related, of course, to correlation. Nice. So let me erase this. While look, while I erase the board, be or get busy liking the video and sharing it. Okay. ولكم الأجر. Okay. Nice. See, Karim, you are saying something very important that I was intending to leave until the end. That's true, my friends. الله يخليكم. When you have the results of correlation, you embark on correlation from the beginning. So your job as a researcher is just to say whether the variables are related or not related. Now, through correlation, do you have the right to say whether this variable impacts the other variable? No. Can you say, for example, if two variables, watching TV and age, so we have the right of saying that, okay, they are related, of course, if statistics show that. But can we say that watching TV is impacted by age? No. Can we say that watching TV is the result of people's age? That's why there is this activity of watching TV? No. We don't have the tools, okay, the statistical tools to do that. This is done by another module, another statistical measure, which is more advanced, which is regression analysis, which we'll cover, of course, in the days to come, inshallah. All right. Nice. شوفوا Natalie, okay. Natalie Leblanc says correlation shows if two variables are connected, while regression takes it further by using one of the variables to predict another. How eloquent this is, Natalie. Thank you very much. Thank you. Mustafa Morshid is saying, my friend, Prof. Dr. Mohammed Boysan, has used correlation and regression in his doctoral dissertation. I learned a lot from him when we were working together on our doctoral dissertations. So Mustafa is mentioning the thesis by our friend and colleague, Si Mohammed Boysan, where he used not only correlation, but also regression. Why? Because there is a hypothesis that does not talk just about whether they are related or not, but which variable predicts this behavior or this. You see, so that's the thing. And by the way, correlation is a very good, important step to regression analysis. Okay? All right. Gulmi Matichin is asking this question, a bit related to the lecture. Are we obliged or are obliged to be more specific if we choose the mixed methods approach, such as exploratory, or is it not necessary to be more specific? No, you mean in your methodology when you name your design? No, it's better to define your design, and not only to define it, but also to justify it. Okay, so you really need to say everything. Not everything, but to say the maximum you can in your methodology. The methodology chapter is thick only because it's a space where you express yourself about every single step and the justification of those steps. Okay. Yeah, you need to classify just to show to people that you are aware of what you are doing, and that you did not select a given research design haphazardly. No, there are good grounds for the choice of a design. Okay, can we move on, please, ladies and gentlemen? Mamoni says, I will try to watch all the videos. Thank you. There are some videos that can be useful for you, Mr. Mohsin. Some issues relating to language, some issues relating to introductory courses in linguistics, to writing, etc. So if you do that, I think it's a good thing. Okay. Now, now that we have talked about these, these elements. So the point so far is that when we correlate two variables, the result will reveal a correlation coefficient called R. R means a relation, by the way. The R is the R for relation. And this correlation coefficient, depending on whether it has a plus value or a minus value, zero value means it's a, if there is no plus or minus, it means automatically it's a plus. Then we can speak. So if there is a minus, it means it's negative correlation. If there is no negative, it's a positive correlation. If it's close to zero, it's a weak correlation. If it's close to 1 or to -1, it's a strong correlation. مزيان. Good. Now, maybe we will go one notch higher in this. Okay, I hope I will have enough calories to do that, enough energy to do that. Okay. Okay. In statistics in general, especially in inferential statistics, a distinction is often made between parametric statistical procedures or measures and non-parametric statistical measures. What is the difference between a parametric statistical measure and a non-parametric statistical measure? There is a whole story to tell in this regard, but I don't know if you will find it of relevance or not. But anyway, parametric, okay, parametric, non-parametric. In statistical measures, we have two branches. Either you go parametric or you go non-parametric. But what's the difference? Generally, people would prefer, just like that, they would prefer, parametric tests because of the, or thanks to the assumed strength that they are characterized with. They are robust. But why are they robust? Okay, they are robust because parametric tests, my friends, are based on the mean. That is to say, the x bar, which refers to the sum of xi over mi. Why this? Terre à terre, huh? Just to explain parametric. Parametric tests work with the mean. What does it mean work with the mean? They take as a starting point for the analysis the mean. which is calculated as like this. You have 10 people. One has 11, 12, 13, etc. How do you find the mean? It's by adding up each score and dividing it by the 10 people. You obtain the mean. What is the advantage of the mean? The advantage of the mean is that all the scores participate in it. Okay, so that's fine. The mean. Because all scores participate in the formation of the mean is a very strong measure, is a strong starting point for a statistical analysis. Okay. So parametric tests are tests that work with the mean. Non-parametric tests are generally for data that are based more on ordinal data. Ordinal, like the median. Let me write median. The median, okay, like the median, like this. I will show you very briefly why median is important, but not as important as this, not as revealing as this, okay? So just imagine, I can write here, I guess, I have these scores, and the letter 3, 4, 5, and then I have 20, and then I have maybe 90. Now I will show you, those of you who don't know, because some of you already know this, I will show you why median can be less robust than the mean. Okay, so imagine we have ordinal data. We have data anyway. We can order them from the lowest to the highest. One technique to find the median is to look at the one in the center. 1, 2, 3, 4, 5. I have 5 here. Where I have 5 numbers. Is this the center? No, that's not the center, because I have 1 to the left and 3 to the right. That's not the center. Can 5 be the center? Yes, because I will. Okay, this is the center. I have 2 to the left. I have 2 to the right. We call this the median, la médiane in French. So it's here. Now, I am using this specific example to tell you that while in the mean, all the numbers participate in this value that you have here. For example, the mean is 13. But where do we get 13 from? It's by adding and dividing. Here, if we assume that 5 is the median, what is the problem? The problem is it's not logical. It's good, yes. Technically, it's the median because it's the middle point. But it's a shame, okay, to say, well, we have 3 and 4 before, يعني الفرق بين 5 و4 و3 ما نقيطات عادي. But الفرق بين 5 و20, it's too much. And 5 and 90, that's even more. So this is not really, it's reliable, yes, but not as robust as is the mean. So the researchers who opt for parametric tests are believed or assumed to adopt a test that is robust enough because it's based on the mean, where all the numbers participate. All right? Good. Non-parametric, it's somehow weak in a sense, all right? So we have started with this. Now, in correlation analysis, do we have a distinction between parametric and non-parametric? Yes. Okay. Yeah. In non-parametric tests, Natalie says, the median value is the central tendency value of the media, of the data, because we have different central, la tendance centrale, فيها the mode, the median, and the arithmetic mean. And the arithmetic mean is the one that is strongest for the simple reason that it takes into account all the data or all the scores of the distribution. All right, nice. Okay, so we can talk about parametric and non-parametric data, and then we move on. This is just for concepts. This is not technical. Please remind me to check whether the screen sharing issue has been solved, because I tried to do something to fix it. Okay. And now we come to a relatively important point, because some students, some beginning researchers specifically, may not know about these types of correlation. Generally, there are mostly people are mostly talk about three types of correlation. Okay, two major ones and another one. Okay, let's talk about it. Types of correlation. So we'll talk about the types of correlation and when to opt for this type or the other type. All right. So we have types of correlation. The first type of correlation is called Pearson's correlation, or Pearson product moment correlation. Let's use it here. So we speak about Pearson's correlation. Or just Pearson. Okay, we have Pearson's correlation. Then we have the second one that is referred to as Spearman's correlation. And we have a third one called Kendall tau. Okay. Or Kendall's, correlation. Kendall with double L, I was checking this. All right, Kendall tau. Now, what's the difference? When do you opt for this? When do you opt for this? And when do you opt for this? The answer resides in whether, number one. Okay, so it depends on what? This depends on whether, what type of data you have, type data. I think I need to hold a live session to talk about type of measurements that you have. You have nominal, ordinal, interval, and ratio. But never mind. So if the type of data here is continuous in the form of scores, you see, then obviously, the first choice is this from day one, from the first, your first attempt. Now, if your data is ordinal, then it's better to revert to Spearman-Rhodes correlation. So the first factor that can impose on us, whether we will go Pearson or we will go Spearman, is the type of data, the nature of our data. If our variables are continuous, like, for example, scores, you have 1, 1.5, 2, 3.3, 4.5, 7.57, etc. So any increases like that, it's continuous. Of course, that's more amenable to, or that's more conducive to Pearson's analysis. All right, good. Now, just in case you have data that is ordinal, where, for example, you have 1 corresponding to the first, 2 corresponding to the second, 3 corresponding to the third, etc., where data, are classified, are rank ordered, where there is rank ordering, then automatically you opt for this. You cannot opt for this. Because in ordinal data, we don't have the mean. We have more the median. Because when you order, you have a middle point. That's the median. So it's good to work with ordinal data, to work with Spearman's correlation. Okay. Now we have the remainder. The third one is Kendall's tau, and it's exactly like Spearman. It's like Spearman, but we resort to this normally. This can be a good alternative when the sample size is so small. With smaller sample size, we generally do not opt for Spearman just in case our data is ordinal, but rather we opt for the Kendall tau. All right. And of course, so this is one, criterion for choosing this or that, okay, statistical measure, correlational statistical measure. The second situation where we can opt for one of these is whether the data is normally distributed or not. And I don't think I have enough energy to open a bracket and talk about that today. Suffice it to tell you that in case the data is normally distributed, you initially have continuous data. So you opt for this. بالحق, if this continuous data violates normality, you also go here. Even if your data is continuous, even if you want to go parametric, but your data is not distributed. شنو هي distribution? It should have this shape here. Okay, something like this. This is not normally distributed. Look, this is not normally distributed. This is not normally distributed because it does not have this bell shape. So if the data does not, there are ways for you to do that, but maybe we can talk about this. If there is interest, of course, in this, we will cover the respect in which data can be, shown to be, normally distributed or not. Okay, good. So even if the data is continuous, you cannot go Pearson unless you satisfy this normality condition. If you run the analysis for normality and you have this continuous data and you want to run Pearson, no, you will switch to Spearman's or to Kendall if your sample size is so small. Okay, so that's why Pearson's correlation is the parametric type of correlation. So in correlation, we have parametric test, a parametric test, which is Pearson's correlation, but we have other non-parametric choices, okay, like Spearman's correlation or Kendall-Tau, but there are others, of course, but these are the ones that are major, okay, nice. So if there are probably questions later on, we can answer them, and I'm looking forward to probably holding other live sessions just to explain some of the things that we mentioned in passing, because the information needs to be complete and the picture needs to be, complete for our here. Nice. Now, just imagine we forgot to talk about this, but anyway. So shall I assume that you understood this? I hope so. You can go back to the video and appreciate, if you like these things, real listening and okay. Excuse the noise. Thank you. Alors, I'll talk about, there is one specific thing, because there is there are some questions relating to the situation in which we have, for example, categorical data like gender and the choice of the phone, okay? The choice of the phone is what? How can we operationalize this choice of the phone? You will have either brand X or brand Y or brand Z, let's say. And we know we want to see whether the gender variable correlates with the choice of the phone. Is it, for example, a tendency that females choose this phone type or not, and males choose the other type of phone? So our data is neither ordinal nor continuous, but it's categorical. Okay, so here the option is to use, as Si Mustafa Morshid rightly says here, chi-square test of independence. It's called the chi-square test of independence. Okay, Ahmed, I'll do that in a moment. Thank you. Yeah, that's a good question. You see, so there is another one called Kramer's V test, but chi-square is the one that is the more popular of the two. All right. So we will come to the different scenarios where we will probably hypothesize, we'll make up hypotheses, and then with some practice, in hopes that the screen sharing property, or works perfectly. If it works, it means it's we can start SPSS sessions very soon. Nice. Si Ahmed says, but he has retracted the message. Does this mean that you have withdrawn your question, Mr. Ahmed? Because you talked to me about, you have made the kind request of clarifying or shedding more light on the. Could you explain what hypothesis is? Okay. Now, in research, you have hypothesis. It needs. I think there is a video. There are videos, Si Muhsin, that you can revisit. You see, on my channel, I explained that very well. But a hypothesis in this type of research, just for you to know, it's when you make a sentence, a statement, before you collect your data, where you guess what the result will be. For example, I can say males are more accurate writers than females, or females you choose females are more accurate writers than male, and you collect your data and you analyze and you prove or disprove the hypothesis. That's what I can say about it for the moment. Okay, good. Si Ahmed, do you still hold your question, or just have you withheld or withdrawn your question? I don't know. Inshallah, Mr. Gulmina teaching, I will do that. Let me on the spot see if I can wait a minute, if I can share the screen, and then you have la fenêtre, tout l'écran, la fenêtre et l'onglet. Ok, donc dans ce cas-là, je vais mettre la fenêtre dit. Je ne sais pas si je peux le faire. Live streaming. Okay. Yeah, I don't correlation analysis. Practice. Okay, let me see this. Has the screen? It works, I guess. Arrêtez le partage. Is that fine? That works perfectly. So we can start very soon. Yeah, thank you very much. Thank you. So, it means that I was a good. I was good at repairing my software here. It was related to the browser. All right. So I think that we leave the assumptions now that 1 hour and a half has almost elapsed, and that energy has started to give out. But still, we can reserve time, enough time, more time now in this session to discuss probably other topics, not or related topics, but ask your questions. Foire aux questions. So, you can ask your questions here. Tout en étant énergétique, right? Nice. Yeah, are there questions you probably need to ask about anything related to research and to this, you see, to this specific live session? How can we decide on the relevant information to include in our results? Very good. This is very good, In your results, this is a very nice question. Natalie is, when Mustafa, or I think or Si Bougnifi or Si Mustafa, said that you are a doctorate holder before, holding the diploma, that's fine. You are showing very good knowledge of you are asking the right question, especially that you're involved in thesis writing. Okay, never mind. So how do we decide on the results? Let me answer your question in two parts. Part one, wherever there is a hypothesis, there is a way of rejecting its null equivalent. Well, in quantitative data analysis, when there is a hypothesis, it means that there is a null hypothesis. For example, there is a difference, or there are gender differences, or males differ from females in their production of something, of writing or whatever, in their accuracy on a written test. The null hypothesis is that there is no difference. So your attempt in conducting a statistical analysis is primarily to reject the null hypothesis. So what we immediately do is reject the null hypothesis, on the basis of which we can retain our research hypothesis. But how do we do that? Yeah, there is always a number, except perhaps for some statistical measures like regression, where you have a number of steps, of course. But in a statistical measure like correlation, then the relevant information is what? It's the R value. It's this R equals, and then you have a number here, okay, whatever it is, you take it, and that's the basis of your analysis. In when you use SPSS, sometimes this value is flagged by 2 or 3 stars, and then you have a footnote here showing that this is significant. So here you will do 2 things in this specific case. You will report this number. In other words, you will take this number and you will make the claim that it is a positive or negative or strong or weak or whatever correlation. And if there are these asterisks here, superscript, usually they are written like this, 1 or 2 or sometimes 3, it means that the correlation is significant. So this will add to the fact that, this will add to your claim. You will say, well, not only are the 2 variables strongly related, but this strength is significant, which is a good thing. Now, of course, that's the core part, that's the necessary part, the part that should not be missed, because that's the backbone, that's the number 1 score that can help you reject the null hypothesis or retain the research hypothesis. It's this. Before that, should we report anything? Yes, we should. For example, we can remind the reader that we have this and this number of students and how many groups, and you probably need, by the way, you need to talk about the assumptions. We have not talked about that. For example, the normality assumption, before, for example, the data satisfied the normality assumption, etc. Therefore, this has led us to the running of the Pearson product correlation procedure, etc. And then that's it. But there are certainly pieces of information that you should not, but that are likely to distract the reader, to make the reader out of focus, because the SPSS, the software that you are using, generates far more data than you will need. So what do you do with this type of data? All that you need to do, so take what is necessary, like the elements that I talked about, and the rest, the data as it is. And this is not done by so many students. And this is a piece of advice. So what you need to do is save that statistical output as it is, without modifying anything in it, and put it in the appendix. That way you are showing to people, to your readers, that you have done the work in the right way. And so they will have to have, if they want to go back to see how genuine your data is, they can go back to that. In some statistical tests, you see, for example, the ANOVA test. Of course, you need to talk about the Levene's test to see if the homogeneity assumption is met or not. And then you will report the main result of ANOVA and then the post hoc. See, like 2K and GFA. Well, in regression, you need to talk about the model summary table to take the adjusted R square, and then you will move on to the ANOVA table, and then you will move on to the coefficient table. That's a 3-step process. Okay, but just to the bottom line is that you are right in saying that, in asking the question, what information should we include? We cannot include all the information, because that will not, number one, that will not be relevant. some information that is generated by a species is not relevant. Number two, it's likely to distract the reader and to make him lost or her, okay, lost in reading the results. So it's good to give all and only the necessary information. The rest you can, leave until the appendix. Of course, you can open a bracket every now and then, see appendix, blah, 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 for more detailed results. Okay, thank you very much, Natalie, for instigating this discussion. Faiza says, perfect, Professor, thank you so much. Probably that was a reaction to the sharing of the screen. Thank you. Sisaid Rafi says, when can statistics be used in theoretical linguistics, considering that research is exploratory, or does the nature of research necessitate the applicability of statistics? Thank you, Sisaid. شوف, practically, statistics can be used in any single field. So it's not field dependent. It's not field specific. Statistics is not field specific. Take any issue in theoretical linguistics. If you want to insert statistics there as a way of analyzing your data, you can do that. What can make you, contrive a plan for using statistics? By formulating a hypothesis that cannot be answered except, you see, when you have, for example, numbers. A well-known, example is the example of Labov's analysis of certain pronunciations of the R. The R, the R drop, the R in American English. And, that was done by statistics. Normally we know that in studying the phonology of R or the sociolinguistics of any aspect, you can do without. I mean, you can just theorize and you can analyze and but it turns out that phonology, which is and sociolinguistics, which are traditionally probably classified under the basic elements of theoretical linguistics, but there are statistics. But even in a course of phonology, in a thesis that is purely phonological, you can, for example, let me give you an example, Sisaid. Just imagine that I study, for example, the process of, let me look for a process that is a bit irregular. Let's say spirantization in Moroccan languages. I will not say Amazigh, because in Amazigh it's evident that there is spirantization, but spirantization is in Moroccan Arabic. Do we have spirantization of the voiced and the voiceless velar stop and th? Okay, the in the Rabat region, no, and in most of the regions, no. People are more likely to say الحوت than الحوث. People are more likely to say الاثنين than الاثنين. But does this mean that there are no regions that do that? There are. Now, when you go to the region to study the spirantization of this specific sound, which is the voiceless and voiced, okay, alveolar stops that turn into fricatives, you will likely find that this is not a point of agreement by so many native speakers, or this is sensitive to certain isoglosses, to certain regions, or there are certain factors that make people spirantize, and certain sociological, sociolinguistic factors that make people despirantize or not spirantize. You see? هنا غادي يدخل statistics, because you will talk about the tendency. You will run. You are doing phonology. Yes, your thesis is, has analyzed, provided an optimality theoretic analysis, for example, or any other model of pronunciation. But there is this room for checking. If you want to know how widespread a given process is, one way of doing it is to do it in terms of numbers, statistics. So give me any discipline and I will contrive a research question or a hypothesis that will be conducive to a quantitative analysis. All in all, and that's the bottom line. So using statistics or not using statistics does not depend on the field at all. It depends rather on the research questions within that field. In second language acquisition, not all studies have been using statistics, have used statistics. There are studies that address questions that are, more that are better analyzed by means of qualitative data analysis, right? Nice. Okay. Thank you, Said, for this, very important question. Rania Germany, hello, professor. Is it possible to try and correlate between four variables to show comparison on SPSS, especially when generating the visual representation? Is it best to use just two? Thank you. Rania is asking a very important question, and this is why I would like to spend some time reacting to these questions, or from this question from Rania. Okay. Okay. All right. Now, just imagine, Rania and our friend here. Imagine I want to see, for example, the variables of age. Okay, I have gender, maybe economic group, well, or let's say age. No, age and gender. Let's choose variables that are that can be continuous. Age, years of experience. Okay, salary, okay, years of experience at work, salary, all right, and maybe motivation, how motivated someone is. Let's say that we would like to correlate these with, job satisfaction, productivity, and maybe other, let's say these. Okay. How many do we have here? We are correlating these with these. Okay. Now, when these are taken as separate variables, the model will generate a table where all these variables can correlate with all these variables, to the point where in the table that will be generated, you will have age correlating with age. And let me illustrate it again by drawing a tentative table. Okay. You will have something like this. Okay, so let's call this variable 1. Yeah, باش نكتبوا years of experience with age, variable 1. And then you have variable 2, variable 3, and variable 4. Fine. And here you have, and of course, when you run statistical analysis, you can have also the other variables here. Okay, for instance, V1. I need to write to sorry sorry, I'm lost. Okay, just to show. So here, let's call this V5 and V6. Okay, so V1, V2, and then you have V3, V2 like this, and then you have V3 here, V4, and then V5, and then V6 here. Here you have the same. We have V1, V2. That's what the statistical output usually does. Okay? Okay. V3, V4, etc. Okay? And inside you have numbers. And numbers here correspond. So for example, V1 and V1 because it's the same variable, we are expecting a perfect correlation. So في الغالب تعطيك واحدة هنا. Here you have V1 and V2. It gives you a number, and sometimes it gives you even the stars here to show if it's significant or not. هناك يعطيك le coefficient ديال le R. And same thing here, same thing here, same thing here. Now just imagine you have V1 and V2. V2 and V1 will be the same. Donc الرقم اللي يكون هنا هو اللي غيكون هنا. علاش؟ Because here V1 and V2 is the same as V2 and V1. I hope you understand me. And of course, you as a researcher, you can select the variables you want to correlate. The ones that correlate in your study. Of course, you will not select V1 and V1 because it's not part of what you're looking for. So the conclusion, I think it was Miss Germoni, je pense. Rania Germoni, yes, Rania Germoni, one who asked this question. Yes, there is a possibility. You cannot do them. Now, at the end of the day, you analyze it, you take them on a one-to-one or on a 2-by-2 basis, x and y. But you cannot, that's the mistake, the potential mistake that some students can make. It's you run them, you run these two, and then you run again these two, and run again. No. Just insert them at one go. You can say these are the variables that I will correlate. And by the way, اسمحوا لي واحد الحاجة نقولها لكم هنايا وهي أن when it comes to correlation, variables are treated on an equal footing. They are equal. They are equal in terms of what? They are equal in terms of whether they are dependent variables or independent variables. So the distinction between a dependent and an independent variable in a correlation model is relaxed. It means that the two variables will never be dependent, independent. They are the same. علاش? Because to correlate, they have to have the same weight. You see? To have the same, they are in a relation, so they have to have the same weight and same, importance. دونك هذه القضيه ديال ديبندنت ما كتصلحش في الكورلاسيون في الحقيقه لان لي دو فاريابل sont du même poids. You understand? So you enter all the variables at one go, and the table that will be generated will look something like this, and then you will be selecting the variables because where they meet, the cell in which they meet, it means that's the R coefficient that we talked about, and you can say if it's positive or negative, and you can say what's strong or not strong, and apart from that, you can report the significance level there. Okay, is that fine, ladies and gentlemen? Thank you. That's Germany, Miss Rania Germoni's question, and then I think Si Mustafa is saying something there, starting with "Don't you think?" Don't you think, Professor, that by promoting a statistical culture, we will end up having people obsessed with statistical analysis who will be using stats just... Yes, it has already started. The tradition has already started. That's a worry, of course. There is a very important issue. They blame it on second language acquisition theory, that they were obsessed more with psychometrics. I think there has been an interruption, no? Anyway, so this is an article that was published in 1997 by Firth and Wagner. The article's name is On Discourse, Communication, and something, the state of the native speaker, something like that. But it's On Discourse and Communication, and the role of the native speaker in second language acquisition. All right? So that's the rough title of the article, where they are discussing this very important point. Sometimes it pains to see that people are more obsessed with statistics. It means what? It means that the analysis may not be good, but as long as there are questions that are analyzed statistically, it means that you are strong. No, that's not necessarily the case. There are issues in the field of education, in the field of second language acquisition, psycholinguistics, that are best analyzed by means of qualitative data. Okay, so that's a very important point. Thank you very much. Si Mustafa Murshid. Okay, we have Maryam Abu Abdel Majid. Ustad Maryam Abu Abdel Majid. Hello, Professor. I wanted to ask you, how to merge or combine the results of many questionnaires. I translated my English questionnaire in Arabic and French in espaces. Thank you so much. Well, to combine the results of many questionnaires, I translate my, I understand it, Mrs. or yeah, Miss Miriam, that you have a questionnaire. I need to get this I need you to confirm this to me. You have a questionnaire in different versions, yes or no? In different versions. If this is the case, it means I have a questionnaire, let's say, where I have 20 items, let's say, a questionnaire of 20 items. But because the students who will respond to this, there is a group that speaks Arabic, another group that uses French, that is more comfortable with French, I have translated this. If this is what you mean, then you don't need to merge anything. It's the same questionnaire. You enter the data, so you finish the 15 questionnaire that you have for English students. The 16th should be another copy from the French, in the French version, because after all, what is important is what the student produces, what the respondent produces, rather than the language. You will not enter them as separate questionnaires at all, unless you have a hypothesis that says, well, students will respond more quickly when they answer a questionnaire in French than in English, and I will leave questionnaire type as a variable. But as long as you translate only because you want to facilitate the task for the other students, enter them as normal questionnaires. There is no need to merge. Just treat those questionnaires in other languages as the way you treat them with the English version. If this is the point, please confirm. Usada Abu Abdul Majid, I need to see your reaction to this. Okay, if I understood this way, okay, tell me if I understood it, your question in the right way or not, or the right way or not. Okay. Mr. Ahmed Martu says, could you please clarify the notion of the mean? I will do that without any hesitation right away. And Ahmed, thank you for being a faithful follower of the channel, and you always, show up and you appreciate what we do. You like what we do. That's really nice. Okay. So what is the mean? By the way, let me tell you that very quickly. I mean, in statistics, there are two branches. One branch called descriptive statistics, and the other branch is called the inferential statistics. In descriptive statistics, what is descriptive statistics? It's just one way of using numbers, or sometimes tables, or sometimes graphs, to visualize and to describe your data. So how can we maybe describe a data set of 100 people? One way of doing it is to look at each student and analyze his respondent, and analyze all the items for individuals. How much time do we need? That's number one. And how clear are we when we do it this way? No. So we need to look for a way that is a shortcut that can summarize the whole thing in one number. And this one number can be the mode. Okay, هذو كيسميهم les mesures de tendance centrale, النزعة المركزية كتسمى بالعربية. So we have the mode. Very quickly, the mode. What is the mode? Just imagine the mode simply means that you look for two numbers that repeat, the number that occurs with most frequency. مثلا, I have 2, 3, 4, 4, 5. Where is the mode here? It's the 4, because we have two 4s. So the mode here, it's clear, it's easy. You take a data set wherever there are, wherever there is a number that occurs more frequently than the number, that's the mode. Pass. The second one, I told you about it, it's the median, where you order your data from lowest to highest and you look for the middle point. هذه كنسميوها median. شنو العيب ديال هذا الميديان هذه؟ العيب ديالها هو ان كما قلت لكم ممكن يكون عندي 2 3 ياك، ويكون عندي 4 بالحق انا غيكون عندي مثلا 4 من بعد عندي 49 هنا وعندي 1000 1 2 3 4 5 شنو هو الميدل بوينت هنايا سوري الميدل بوينت is this 4 no it's not the 4 yes it's the 4 عندي جوج ارقام قبل وجوج ارقام من بعد بالحق الفرق بين هذه وهذه جوج ارقام ماشي هو الفرق بين هذه وجوج ارقام which means that the median does not take into account the differences between the points. Median is a good one, is better than the mode, but it's still weak. The strongest measure of central tendency is called the mean or the arithmetic mean. كيتسمى بالفرنسية la moyenne arithmétique واللي كنرمزوا ليها x bar ماشي x bar syntax x bar و la formule ديالو هي la somme de xi sur ni. مثلا نعطيكم un exemple. Imagine we have scores, the following scores. عندي 10 عندي 11 عندي 12 عندي 13 كيفاش غادي نلقى هاد الاكس بار ولا المين؟ How can I find it? It's by adding these, okay, and dividing. So I add up this and this and this, and I divide by the number of cases I have here. 1 2 3 4 نقسمهم على 4. Okay, so هنا ده هسه هي يعني عندي 46 divisé par 1 2 3 4 ça nous donne un chiffre. Can you help me please, ladies and gentlemen, or let me do it by means of the calculator. Anyway غادي نعطيك un chiffre هنايا انت تقلبوا عليه. So you have a number. This number is called the median. I'm sorry, the mean, the arithmetic mean. What is the advantage of this arithmetic mean? The advantage is that it takes into account all the scores. راه شتي هادشي كلشي participa في هاد الرقم اللي غادي نلقاو بحال العصاره ديال كلشي we squeezed all these things into this. Okay, so that's why the mean remains a better alternative than the median and also than the mode. Okay, Reem Saraji, hello, Ustad Reem, how are you? Thank you so much for the insightful session. I have a question with regard to correlation analysis. To what extent can relation be misleading? Of course, it can be misleading. Thank you. Sometimes it can be misleading if we don't control our variables in the right way. It can be misleading. Sometimes there are variables that come into play and we believe, okay, that this variable relates to this variable in a very strong way. There is a strong positive correlation, but this correlation can be spurious, can be fake relation because there are other variables we have not taken into account. And this is not just for correlation, this is over all types of analyses that are statistical that can be subject, it can be the victim to these intervening or confounding variables. That's one thing. The second thing is that a correlation is said to be, or correlation analyses in general are said to be sensitive to outliers. Outliers when you have extreme points, where you have, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. And then you have 2003. That's an extreme number, very far away from the bell-shaped curve. Okay, so in this case, students, researchers have to take precautions. There are certain assumptions that need to be met, and they are likely to reduce the chances of having spurious correlations. I mean, correlations that are not actual correlations just on the face of it. Okay, thank you, Ustad Reem, for this important question or contribution of yours. Thank you. So Mustafa, in linguistics, we can rely on corpus-driven research. Yes, statistics will help us to do the coding. Corpus-driven, that's one thing. But there might be emerging research questions that you probably that the corpus may not, show in any direct way. So you can never predict what possible researchers in the future be interested in. Okay, what are the limitations? Yeah, I think I have talked about this. Limitations of correlation analysis. Of course, it has limitations, and one of the limitations is that it does not. So correlation reveals information only about relationships, whether there is a relation or not between two variables. Does it go beyond that? No, it does not. This is done by other types of statistics. Okay, crucial of which, or most important of which, is the regression or regression analysis. Thank you. Thank you, Natalie. Thank you. Hello, Professor Siraji. Okay. So I think, there's an exchange with Professor Siraji. Hello. So he says, I have read something about type 1 and type 2 error. The problem with misinterpreting data may come from there. Anyway, yeah, type 1 error and type 2 error, are always there. They are threats to the credibility of our data. Type 1 error is when you say that there is an effect. For example, there is a relation at the time when there is no relation. And type 2 means that there is no relation, but you prove that there is a relation. Of course, what does this, how can we control for these problems? How can we prevent these problems from occurring? We can avoid type 1 and type 2, or reduce the effect or mitigate the effect of type 1 and type 2 error by sampling in the right way and by taking every single step with precaution, and also by checking for normality, for assumptions. I think this way we can work towards reducing the effect of these two types of errors. Thank you. Mohammed Zarak, could you please kindly suggest the appropriate test to correlate practices from two perspectives, example, students, teachers, measured through the Likert scale? So practices, how did you score practices? If practices are, all practices from two, practices from teachers, practices from students. I think this is more, so you have something, you have students, and then you have teachers, and the two are, scored by means of a Likert scale. This can, if you could transform these, I don't know, if you can transform this Likert scale into a continuous variable, then you can easily run the Pearson product correlation, which is, a parametric version, the parametric test. Okay. Now, if you insist on this ranking of the Likert scale, you have an ordinal data. If your data is truly ordinal, then what you can do is switch to the Spearman rule. Now, whichever test you use, its interpretation and the tables it generates are exactly the same. So the reading of the results for the Spearman and the ones for Pearson are exactly the same, so there is no worry. So bottom line, to answer your question, Si Mohammed Al-Zraq, you have a perspective of teachers correlating with perspective of student, and you said that you have scored these on a Likert scale. Muzyan, very good. Now, one way is to transform the Likert scale into continuous data. What if you want, so that you will have a continuous variable in which it depends on what you are measuring. I don't know. But if the order is crucial to your hypothesis, there is an order there that is explicitly mentioned, and you are looking for comparing these ranking. What here you can go nonparametric. You can adopt or rely on the Spearman rule version of correlation. Thank you. Okay. I think I missed something here. Oh, there is Siraji, and then C. Mustafa. Okay, you are okay. Si Ahmed says, is there a relationship between the mean and the standard deviation? Look, for a while ago, I made the point that we have two measures. When you have a data, you want to look at it in two ways. We have what we call measures of central tendency. It's how close the scores are to each other in a data. And we have three measures. We have the mode, the median, and the mean. Look, it's mode, central tendency, and we are looking for homogeneity in the data. Now, there is an opposite perspective, because when we want to look our data, we are not just looking at the clustering of the points, but we can also look at how spread the data points are in a distribution. And these are the measures that show us how far apart the measures or the points are in a data set. We are talking about measures of variability or measures of dispersion. So just to make a long story short, one of the most important measures of dispersion, yani measure that sees how widespread, how heterogeneous the data points are, is called the SD, or the standard deviation. I think that's the one you asked about, the standard deviation. SD, standard deviation. So you have a point there. Now, let me visualize this here. Just imagine we have two distributions, okay? One distribution has something like this. All the points are here, okay? Fine. And just imagine that the mean here, x bar, is 10, let's say. The mean. I am now showing to you standard deviation, all right? Now, just imagine you have a second, distribution where you have this data, okay? But and of course you have 10 in the mean. إلا جمعنا هاد الشيء وقسمناه غيعطينا 10. إلا جمعنا هاد الشيء كله وقسمناه غيعطينا 10. هاد الشيء central tendency. But if you just look at these two graphs, you will notice that in one graph, the data is clustering in one area, in one region. But here, no, it's widespread, even if the typical number is the same. But here it's widespread, but here it's clustering. So the index that shows to what extent, or the extent to which, the data can be spread, is the standard deviation. And the index that shows how you see data, cluster around one number, is the mean. So this is the difference. So the standard deviation is a measure of dispersion, is a measure of variability, is a measure of spread. الانتشار بالعربية. Okay, les mesures de dispersion in French. Okay, medidas de dispersión. Okay, good. Right. أستاذة هند, أهلا وسهلا هند. أستاذة هند, what are the statistical analyses that should be used to investigate the pre and post scores of a control group and experimental group other than independent t-tests? Should correlation be used as well? If correlation is used in this case, أستاذة Hind, it's just على سبيل الاستئناس فقط, but that will not answer your hypothesis, of course. You see, that will not answer the hypothesis. That will just be, an exploratory type of thing. But these normally can be should be between pre-post scores of a control group and an experimental group. Yeah, I think you have. So let's just represent it here. Pre-post. So there are many steps you can take here. Maybe you can compare the pre-scores for the two. Wait a minute. Now you can compare. Yeah, initially, just to see, you have to find similarity, by the way, between the control and the experimental group before the administration of your experiment, before the implementation of the experiment. But after, you need to, see, you need to check, you need to run this t-test in order to see the differences. I think the t-test is the most relevant here, especially if your variables are continuous. Mostly you will have scores. And of course, you have a measure of comparison. You are comparing the results of a control group with the results of an experimental group. No correlation, I am afraid, will not do the job here. If there is any function for, if there is any job that I'm sorry, correlation can do it, it's just for exploratory reasons. You see, it's just, but you definitely need a t-test there, or an equivalent if your data is not normally distributed. Okay, Ustad Ahin, that's what I got. Now let me reread the question just in case I missed something. What are the statistical analyses that should be used to investigate the pre and post scores? Pre-post. Now, for the post scores, because you definitely need to check, the control and the experimental after you have administered the scores. Or one thing you can do is to check the pre-post for the control group and pre-post for the experimental group. But you definitely need to compare the post-test for the control group, the experimental group, and a test for because you need a post-test even for the control group, just to see if, for example, if there is a new method that you have administered that you want to experiment versus the traditional way. So you need to find the differences to say that your treatment has had an effect. Okay? No, but correlation will not do the job, I'm afraid, because it's just to see whether there is a relation, not you are in experimentation or not. You see? Okay. Manova, if Manova can do the job as well. Yeah, that depends on the research aim, but the point is, a t-test, that is the crucial, the heart of the analysis should be a t-test comparing the post test for the experimental group with a test for the control group. It should be the same test, preferably. You see, to limit all to control other variables. But of course, with other tests to initiate the discussion and to reach this crucial point here. All right, Mamoni, median number is in the middle of the numbers. That's true. Yes. Okay, so the result for the median, that it's 11.5. Okay, 11.5. All right, thank you. I have opened the window and I have the sun rays. That's why I am looking for where to click here. Yes, Mustafa is. Thank you, Usadarin. Thank you. Mr. Mustafa, what should be taken into account? You see, of course, jumping headlong into the instruments and into the formulation of hypotheses is fraught with danger. Why? It's because sometimes you take a path to which there is no solution. You want, for example, to run the t-test, but your data is nominal scale. You see, that's the point. So I think that it's good to plan and to talk to people before and to take precautions, to sample in the right way, and to have your instruments, you see, engineered in such a way that they reflect what you are looking for exactly. And more importantly, it's a good idea to check what was done before, in previous studies, so that you can do the same. Okay. Yes. Okay. So let me see if there are questions before we probably call it a session. See, Ahmed, in data analysis, the researchers usually combine descriptive and inferential statistics. Yes. The point is that even when you opt for inferential statistics is based on descriptives. That's the starting point. And usually you talk about, when you introduce your results, you introduce your data, you definitely need to talk about the measures of, especially the mean and the standard deviation, of course. You see, but they are not mutually exclusive. So doing inference statistics means that you go through the step of screening your data and giving it a general numerical description by referring to, and of course, producing tables and graphs to show the type of sample you have. Yes, Mr. Karim Mulai, that's true. Man-Whitney test is the non-parametric equivalent for the t-test. Thank you, Ustad Hind. Good luck to you. I wish you all the best. Sirab Si Absalam says Spearman rule can be used when the assumption of normality, that's true, is violated. That's absolutely right. So it can be used when the assumption of normality is violated or when your data is ordinal. You see? Okay, I think this is, enough for us. I guess it's a challenge. It's been very challenging, of course, because spending 2 hours talking on the first day of the holy month can be sometimes very challenging. And alhamdulillah, I still keep some energy now, and I don't know the rest of the day, what the rest of the day will be. But anyway, it has been a pleasure being with you and sharing with you these. It's already 2 hours and 15 minutes. That's okay. It's just that there are sometimes discussions with friends and colleagues here that push us to say more and to reflect more on the different issues. Thank you very much, everyone. I can barely read this. Thank you very much, everyone. And an announcement for another live session will be made so soon. Let me know, please, if you prefer it to be in the evening, I guess, after you are done Tarawih and with everything. If you decide, to hold the live session, then it's better than watching the series. Huh? Okay, so thank you, everyone. I wish you a happy day and a happy month. Thank you so much. Let's meet on another occasion. And thank you, Lalla Khadija Anas, who was behind this initiative, actually. So thank you once again and have a good time.